So find the moment of inertia of uniform disk of mass m radius and about its diameter. So can you find out about its diameter?
Yes.
Yes, sir.
So this one about this axis it is for a disk it is mr square by 2. Now they are asking about the diameter. Okay. So about the diameter, now you will use ix plus iy is equal to iz. So in this case, across both the diameters which are perpendicular, okay, it is same. So you can take it as 2ix is equal to iz, and iz is equal to mr square by 2, and therefore ix will be mr square by 2. mr square.
Yes.
Very simple. Not at all difficult. Okay, fine. Okay, friends.
Yes, sir.
So we could all do this. We can do it. Now, among all the parallel axes of moment of inertia of a rigid body, about the axis through which the mass center is minimum. Somebody abstracted this. The moment of inertia about the center of mass is always minimum. Otherwise, mr square will get added. The second term added to the moment of inertia I see about centroidal axis of how it can be recognized as moment of inertia of particle equal to that mass is located in it. It reveals that the plane motion, the rigid body is superposition of pure rotation and of the about the mass center or centroid and the translation of its mass. Anyway, we'll deal with it later. So find the moment of inertia of uniform ring, uniform disk, uniform cylinder, uniform which each of mass and radius about the instantaneous axis of rotation in rows. Can you do this? So we have found out through the centroidal axis. Now through the
Parallel axis.
so through the using parallel axis theorem, you can find out about the instantaneous axis of rotation. Okay, so just do it for one case. So supposing it is a disk which is rolling, okay. This is disk which is rolling. So about this point, if it is a disk, it is mr square by 2. Now about the instantaneous axis of rotation, so you have to shift it by r, isn't it?
Yes.
So this will again be plus mr square.
Yes.
Okay, so that gives us with mr square, okay, into 3 by 2.
Yes, sir.
Yes, sir.
Got it? Yeah, I think you can handle this. See, things start really looking very simple, you know. So if your concepts are clear. So you can find out.
Yes.
About it is 3 by 2r, ring 2 mr square, etc. You just have to add mr square to each one. Okay, friends?
Yes, sir.
Yes, sir.
Somebody said yes, sir. What? Shall I proceed?
Yes, sir. Then, I think.
Yes, sir.
Find the expression for moment of inertia of uniform disk of mass m radius r about one of its secant, making an angle theta with one of its diameter of a uniform disk of mass m radius r about one of its secant, making an angle theta with one of its diameter. Okay, do it yourself.
Yes.
Everybody. So suppose all of you got what is the secant here.
Yes, sir. Yes.
So this is the diameter. So this is the disk, and now we are considering this secant. This is
Yes.
making an angle theta. Isn't it?
Yes.
Okay. So you have to find the moment of inertia about this. So if you take this as C, this as O, this as A, and this as B.
Yes, sir. We can take a diameter parallel to the sequence.
So you have to find the moment of inertia about OB. Okay, that is moment of inertia about OB. That's what you have to find. So that one is a disk, right? It's not disk of mass here. So about this diameter, that is about OA, you know it is mr square by 2.
Yes. By 4.
About OA man,
Yes, sir.
by 4, sorry, it is flat. By 4, mr square by 4. Okay, about OB.
Plus mr plus m square.
Yes, sir.
Yes, sir.
Yes, sir.
Everybody there?
Yes, sir.
Yes, sir.
With this diagram, it will be difficult. Let me write
You can
it.
choose a
Wait.
diameter parallel.
That's right. So take this diameter and take this. So take this as C, take this as O, take this as A, take this as G, right? And this is what they have told. This angle is theta here. Okay, this angle is theta. This is what diameter. Now you choose another diameter.
Yes, sir.
You choose another diameter here and call this as PQ. So this diameter and this diameter, if they are parallel to one another, these two, then you know what is this across this, and you can find the perpendicular distance. Sorry,
Yes.
I'll write it neatly.
Yes.
So this is one diameter that is given. This is another diameter, and this diameter is like this. So here you see this angle is theta and this is parallel. You have to find this perpendicular distance. Okay, so if you write this O, P, then this is Q, this is B, and this is P. This perpendicular distance. Okay, so if you put this, give this perpendicular distance here, CD here, then we just have to use the parallel access theorem and do this. That's it.
Yes, sir.
Okay, and
Yes, sir.
this is not. This is the radius. So if this is the radius and if this theta, so you can find out
R sin theta.
r sin theta. So r sin theta is the distance, perpendicular distance of this from this. So you will have to find it. So along this radius, it is mr square by 4 plus m into
M square.
plus m into this distance. That distance will be r sin theta.
Yes, sir. Yes.
Okay, that's it. Just draw the diagram. You will be able to get it. Okay, friends.
Yes, sir. Yes.
Yes, the same thing. Okay, fine.
Yes, sir. Yes.
So you want to try this. Find the moment of inertia about centroidal axis of a bobbin which is constructed by joining two coaxial identical discs, each of mass m and radius 2r, to a central cylinder of mass m and radius. Basics. The first diagram that I have shown with discrete body, similar thing you can use it here and you can do this.
Yes, sir.
You don't get carried away by the huge diagram.
9m r square by 2.
Very nice.
Yes, yes,
So if
yes.
you remember the first diagram I showed you, so supposing this is a mass m, m1 r1. So what is the moment of inertia of this m1 r1 square? Now if I add one more mass here, m2,
Yes.
and radius r2, and here if I add one more mass here, same mass m2, same radius r2, so the total moment of inertia of this will be m1 r1 square plus 2 into m2 into r2 square.
Square. Yes, sir.
So here instead of this you have got one cylinder here, that is that the D is like this, the cylinder is like this, and then here you have got two D's. So this central cylinder, its mass is m, and the radius they have told is r, mr square, and that of a solid cylinder it will be by 2. Okay?
Yes.
Plus 2 into, then what have they told about the mass? Okay, motion of the bobbin, which is considered by coercion. Two identical discs of mass m and radius 2r and central mass m. Mass is same everywhere. Okay, so this m2 is again m, but r2 will be what? 2r. Therefore, r2 is 2r. Correct now? This one they have told it is 2r. So here you will get here mr square by 2 plus 2 into m into 4 r square. Okay, divided by 2. This should also be divided by 2. Hello? No, nobody is talking. You got how much? 9, huh?
Yes, sir. 9m r square by 2.
9m r square by 2.
Yes. Simple. Hmm. 9 mr square, right?
Yes.
Okay? Good. Last problem. Find the moment of inertia about one diameter of a hollow sphere of mass m, inner radius r and outer radius capital R.